Ionic solids are formed due to ionic bonds between metals and nonmetals, where the metal cations lose electrons to non-metal anions, and this results in strong electrostatic forces between them. So ionic compounds, such as sodium chloride, form solids at room temperature, and due to the strong electrostatic interactions, they typically have a high boiling temperature and also a high melting temperature. And as we saw using Coulomb's law, the strength of the interactions depend on the charge and the ionic radii. So these properties lead to a higher lattice energy, which is the energy required to separate 1 mole of an ionic solid to a gas of its constituent ions. So because the electrons are highly localized in an ionic solid, ionic solids tend to be poor conductors. But if you dissolve an ionic solid, such as sodium chloride, into water, then the ions are free to move around and conduct electricity in a liquid state. And later, when you explore material science, you'll see different arrangements of ionic solids. So for example, in a face-centered cubic arrangement, where the basic idea is that the cations and anions in an ionic crystal are arranged in a periodic 3D array, which maximizes the attractive forces between the cations and anions, while minimizing the repulsive forces.